Okay, hi guys. So, what I'm here to talk about is really my experience with rocket engineering, but more than that, the invention cycle that went with the final rockets we did, which were 6 foot long rockets destined to go a mile high. So, just sit back and relax, and yeah, here's my story. So, let's start with what this is all about. So here's a rough timeline of things. So we start off the year with Intro to CAD, Fundamental Rocketry, and building smaller rockets. And then towards Christmas of that year, we transitioned, and the whole second semester was just the big rockets. And then I'll break down into smaller parts. So we have where I started constructing the larger rockets, then getting everything approved, and the presentations and the approvals that had to go along with that, which were like flight readiness reviews from the FAA and talking with people from Lockheed Martin and that whole ordeal. And then there was the event that actually took place with our launching the larger rockets, and then the events that came after. So this is where it all starts, from how our rockets went from 6 inches to 6 foot long. So we didn't start with rockets. Our first actual projects were building smaller boxes that would contain our smaller rockets for the first half of the year. These were designed in CAD, just to kind of get used to that idea of turning paper into physical products. So we started off with CAD designs, which it seemed really extra for building wooden boxes, but it really got our feet in the water for this sort of idea. On top of that, it started us out with design constraints, like how big we needed to be. We didn't want it too big, but we wanted to make sure we had room for everything, things like goggles, spare papers, how we would suspend rockets, all sorts of stuff like that, which really started the year off right. But then we got into fundamental rocketry after the boxes were done because we had to make rockets to put in the boxes. So we started off learning about motors, how you make things stable, what is stability, what are rockets in general. So this was a little, not terribly far into the year when we started experimenting with the rocket motors, how long they burn for, how long there's a little pause, and then an ejection charge. So this is fundamentally how the larger rockets worked, just at a completely different scale. So once we learned about basic rocketry fundamentals, we started off building rockets. So this started out in a program called RockSim, which is kind of like a CAD simulation program for making rockets. It teaches you things like stability, like the difference between center of pressure, center of gravity, and how you balance those two things to make a rocket stable and not corkscrew and flip off into the woods. That and how do you make things fly? Different things go into this, like fin shape, how big they are, the surface area, and dozens of things. And this, about 1 week or 2 weeks of learning fundamental rocketry was like taking a year's worth of physics. So like, what sort of fin shapes affect stability? How do you minimize corks? Yeah, and all that. So with the first rockets, things got bigger. We went from smaller, about 4-inch rockets to almost 12-inch rockets, which we thought was a huge change at the time. From starting out building wooden boxes to making these, one was a big change, and two was a whole lot of fun. But 3 out of 3 of my rockets that I initially built failed, which was kind of a big heartbreak. We were about to go into this transition of going from Christmas break to building rockets that were 6 foot long. And it really made you wonder, is this really worth it? Am I going to put in the time to just have something that fails? And that was probably one of the biggest points that everyone kind of did a little bit of self-reflection of, is this really worth it? I think some people dropped, but a lot of us really went to go look at the drawing board, see where we went wrong, and then applying those different areas to what was coming. and that's what they should look like. But none of mine look like that. And then it was time for the main project. This was a transitionary period, like right after Christmas break in high school, where we went from rocket engineering being little 12-inch rockets to getting introduced to a whole different scale. So, like the first semester, we started off making wooden boxes. So the image you're seeing to the right is I think it was a 1/5 scale image of what the actual rockets would be, kind of dimensionally. That's just a 1-inch wide construction of one that we could use to help get it approved. Because now we actually had to give things approved. We were doing multiple presentations for every aspect. And one of the ways we proved that our rocket box would be both sturdy and, could support the weight of a human while still being big enough for the rockets, was we took our biggest group member and we had him stand on it. And that even the little 1-inch wide section made it. So that raised our confidence with building the box this way. So then we got introduced to what the real aspect of the rocket would be. Starting out, all we really had was a budget and a goal. So what were the goals? We had to get a mile high, which doesn't sound that much, but when you get down to the 5,280 feet and all that, it really gets put in a new perspective. So that, and we had a live 1-pound payload. So for us, we used a 1-pound bottle of water, which had a triop fish. They're like little horseshoe crabs. So that was our payload. Other groups did other things, but that was one we with. But really all I had was a $700 budget and a prayer, which was really scary. So this is when the pitfalls really started to come. So some of our first thoughts was, why do we even do this? This is going to be a huge undertaking for the next semester, and do we really want to invest that much time? And where do you even start? This whole thing started out with a massive packet being put in front of us and pretty much saying, here you go, find your own products and build a rocket. And that's really what we had for our group, which was really scary. But getting through this was definitely, we were really reliant on each other with this, which was having each other and supportive group mates is definitely the thing that kept everyone going. That positive input and making a positive output really, really helped the decision making going forward. So after we built the boxes, we had to build a rocket to put inside of the box. So this was about a 2.5 week period. The first 2 weeks were product research, learning what goes into a rocket. Do we want Kevlar shock cords? What do we want the body to be made out of? What material are we going to be sourcing for things like fins and spacers, bulkheads, down to what U-bolts are we going to use to connect things together? Is this whole thing going to be a metric-based system or a standard-based system? What altimeters are we going to be using? And from what I remember, the original Excel sheet was around 70 items that we had to purchase while staying within that $700 budget. And I'm trying to kind of get through this quickly, but there was a lot of aspects that went into this. I think there was at one point 14 of us trying to figure out what we really wanted, what we needed, and how we were going to stay in this goal. We had priced it out once, and for everything that we really wanted, we were well over, I think, $1,500. So we had things like cutbacks, different products that we switched out, which we eventually did finalize. This was definitely the biggest stress moment for everybody. That plus we all got together and spent about 3 days making up CAD designs for the rocket. And 3 days doesn't sound like much, but when you have this many people surrounding one computer monitor worrying about what things to change, what things to keep, how do we get somewhere with keeping all these changes. That was a big deal. So that about 2.5 weeks was really stressful, and we had no clue what was coming for us. So after we found all these products, we had an initial rocket design. We had to do a critical design review for about 7 select people. So this definitely was the most stressful day of my life, this next presentation that had come up. We were presenting in front of 5 key people from Lockheed Martin. Of course, we had our teacher, and the dean of students even attended this. So we all dressed up for this. In the crowd, I mean, there was, I believe it was the head of maintenance, some of the engineers that are responsible for building some of the aircraft and rocketry stuff at Lockheed Martin. These are all people that we looked up to, people that we knew by name that we got to meet, and all came to volunteer their service at the high school. So of the 7 people that were in the crowd, we got 5 no's and 2 yeses. And the 2 yeses only came from our teacher and the dean of students, which I think they said yes because they were a little biased. But all 5 of the original people from Lockheed Martin explicitly said no. They would not fund our rocket. And it seemed like really only our rocket was the one that they said no to. So we had a lot of changes. The original document, when we were piling together all of the things that they had a problem with, was over 2 pages of just things we needed to fix and things we genuinely had not have thought of. So getting over this was I would say the biggest pitfall in all of this. This is the point in the invention cycle where we all looked at ourselves and said, is this really worth it? But it was definitely our team coming together, seeing a goal, and wondering how we were going to get there. And that's really all that kept us together. But eventually we did, and we did a whole nother presentation saying that we were ready, all the changes have been fixed, and that, well, we were going to be able to do this. So after the presentation, we finally got to start building our rockets. So this was another couple of months after this, when we started finally getting products together, when we were finally starting to put the puzzle pieces together. So included in this photo, there's a few main points I want to talk about. So this was the main body tube, this blue section. Even the little bits like trying to put these holes or these routed slots for the tabs of the fins. So here you can see one. I actually believe they're stacked up. So we had our triangle fins, which one of our group members took a CNC router and was able to route out all of these fin shapes, the different bulkheads, the rings that held smaller body tubes in the body tube. Just the little things like that we didn't think of. Like this, we had to make a whole jig and use large routers to cut those out to make sure they were 100% straight with the body tube. And really just bringing everything together. And this is when we really were split. We had to divide and conquer as we were getting closer and closer to launch date, which is the event I'll talk about here later. But we had everything together. We had the bottle where we would store our fish, all the water that it was going to take. Here's the motor that we actually ended up using, with a larger fuel tank, a solid fuel portion. The orifice isn't in it, but that's pretty much the driving force of the rocket, and I believe it was a little over 2 foot long of just solid motor. But yeah, this is when we were really pushing things together. The due date was coming up. The event that was the actual launch of all this was soon to come, and we were riding that deadline very hard. So just after that handful of months, we went from doing these smaller rockets which we thought were huge, to doing these 6-foot rockets, which ultimately were a whole lot bigger than any of us could have imagined. And then when we got there, we had done it. This was the day before. This picture was taken the day before the deadline, so the event was the day after this. And we had done it in the previous picture. Here, let me go back. Oops. Okay, so everyone in this picture, this was a whole nother group. But everyone pretty much in this picture and a few other people were all people field tripped out and had spent days out of school working just on these rockets to make sure they met the deadline, because in the end, if you didn't meet that deadline, it really kind of all fell for nothing. So if it wasn't for a few of my group members and everybody else, I don't think anyone really would have finished. But even with all that, it did pay off. We did get it done, and we were ready for the event, which was coming the next day. So then came the launch. We all met up at the school at 3:30, ready for this event. So this event was an FAA event where there were people certified from all walks of life to launch these rockets that were going to go a mile high. So this event really was remote. It was a few hours west of North Richland Hills, into a really remote area, dirt roads, crossing creeks to get to the event, and really was when everything started to come together. So this was, once we had our rocket fully constructed, we had to go through what's called a flight readiness review, which was definitely one of the most scariest things I'd ever done. So this is when they go through dozens of checkboxes, which things your rocket has, which things it doesn't, and you need a 100% score to pass. And this is definitely the moment where your rocket is going to fly or it isn't, and there's nothing really you can do. This really was just a sketchy old building. There was no tools, there was no going back. If you failed here, you pretty much just went home at this point. But thankfully we passed. You can see here this was the original packet. I think there was actually 4 or 5 pages front and back of check boxes and all sorts of little things. And then it was time, after we got approved, I think a couple hours had passed, we were going to the actual launch site, which was, I believe, another hour and a half or so ride. Everyone was scared. Everyone was, it started out with everyone being really quiet, like we were on our way to war, but this was the point where a year's worth of work came together. All of our rockets had passed inspections, and we were within hours of launching something that we had spent a year on, that we had spent countless hours of blood, sweat, and tears. And if it worked, and we could all jump and laugh, and if it didn't, well then, it really was all for nothing. So the whole year relied on today, and everything was super quiet. Everyone was super scared. So to kind of try and break the ice, we started a song. And yeah, you can imagine how that went. The bus driver was beating his head on the wheel, pretty much. But we started to get everyone to get to smile, which was a really big thing. So then we got to the event. We went through a whole nother review process, which we didn't know about, where they loaded things like the blasting caps full of gunpowder to blow the rocket in 3 different pieces to help. When the rocket comes down, it has to break into multiple pieces to deploy parachutes. So there literally was bombs going off in the rocket to make sure parachutes deployed, the configuration broke, and all different points. So really quickly, this was our launch, which is in slow motion, so let me go forward a little bit. Okay, so here's our rocket. Which this was the point where everyone really smiled. This was a really happy point in what we were doing. This was a year's worth of work that went up, and it went up straight, and it went up right. And even right there, so you'll see these white lines go across the screen, and that's just glare from the sun. Because the rocket was going up really fast, and those white lines are just reflections from the camera lens. Because I was pointing my phone almost directly into the sun at an angle to make sure we got the rocket. And just because I don't think that did justice, here's another launch. This one wasn't ours, but just so you can kind of hear the rocket and see how other groups did.
4, 3, 2, 1, ignition.
And even the microphone doesn't give it justice, but they were super loud, super fast. Even a couple did cartwheels and spun out and came towards the crowd. It was a fun time. But it was a long time. We had been with each other from 4 in the morning with no one sleeping because we were all scared to sleep through the event. So everyone just stayed up all night. We got together at 4 a.m. I think we got back at 7 or 8 o'clock at night. So everyone was exhausted. Wasn't just me, which you'll see here. So this is everybody. This was the 6 of us that built the rocket, that fought through everything. We were all super tired. I think our launch time was around 3 o'clock in the afternoon. So to go from 4 a.m. to even there we were all passed out on the ride back. And thankfully, we first started out with pizza, and I think we spent 2 days watching Interstellar and just having a party about it because it was a huge accomplishment. We made it through. We launched a rocket, and in the end, it worked, which was a huge surprise to a lot of us. But then after this, we went to the Fort Worth Science Museum and spent a day doing a little expo where we, for maybe 5 or 6 hours, had exhibits out for kids where they can come up and, touch the rockets and see the parachutes and stuff like that. And we brought our Triop, which was our 1-pound payload, which was a pound of water with a little fish in it. And he survived, so they got to see him. And it was a fun time. We got to see exhibits early that they weren't planning on releasing. I think it's open now, but at the time it wasn't. In the Science Museum, they have an Apollo exhibit on the second floor with 3D mapping and stuff like that. But yeah, we had finally done it. And at this expo, people like the Lockheed engineers that originally had said no. This was probably 5 months, I want to say, after they had seen us last. They came and saw all of our accomplishments and watched all the videos, and this was more of a pat on the back experience for us, seeing everyone that said no smile and give us attaboys for this, what was a huge accomplishment. And realistically, this was the last thing we all did in high school. And it was a beautiful end. We didn't quite make the goal that we wanted, which was a mile high. We did go 3,092 feet, though. We're forever commemorated on these plaques that are still in the rocket engineering part of the school. And these little placards are the end caps from our rocket boxes. And everyone had taken a picture with their rocket beforehand. Yeah, this was a memory that not only will last forever, but it taught me things like presenting when you're scared out of your mind, how to get through adversity when it hits really hard, when you literally have no other clue what to do but then to give up, how to get through things like that. And all in all, just be a really fun experience for my last thing in high school. But yeah, thanks for listening. If you have any questions, my email is out there, and I'll be able to answer anything. This originally was supposed to be a physical presentation, but the virus has shifted us online. So, yeah, thank you.